All right, guys, we're going to get into chapter 5 now, and section 1 is solving inequalities by addition and subtraction. So previously we solved equations using addition and subtraction, and now we're going to solve linear inequalities. Make sure you notice that it's inequalities using addition and subtraction. So there's a difference between an equation and an inequality. And I think you know some of this already. But some new vocab, we're going to talk about what inequality means and also set builder notation. So just a little problem to give you an idea of how this stuff works in the real world. So the data in the table shows the recommended daily allowance of calories for girls 11 to 14-year-old, right here, so 1,845, is less than the girls between 15 and 18-year-olds, so 2,110. So that means that 1,845 is less than, because it's not equal, it's an inequality, it's less than 2,110. So if a 13-year-old girl and a 16-year-old girl each eat 150 more calories in a day than suggested, the 16-year-old will still eat more calories. So that means it's kind of like if you add 150 to both of them, they're still going to the one's still going to be greater than the other. So an open sentence that contains these symbols, this is less than, less than or equal to, or greater than or equal to, is an inequality. And that example we just looked at illustrates the addition property of inequalities. And what it says is that if one number is greater than a number, or one number is less than another number, and you add a number to both sides of the inequality still holds true. And it also works if it's greater than or equal to or less than or equal to. So we can use that to solve inequalities. We can use that to solve inequalities. So if I solve x minus 12 is greater than or equal to 8, I start with the original inequality, and then you could get x by itself by adding 12 to both sides. Now, when you add 12 to both sides, the addition property of inequality says the inequality still holds true. So the 12s would cancel, and 8 plus 12 is 20. So that means that x has to be greater than or equal to 20 for the inequality to be true. So the solution is the set of all numbers greater than or equal to 20. That's what that means. Now, you could check this by check a couple different numbers that are greater than or equal to 20. So if I put 20 in, it would work because 20 is greater than or equal to, that's the or equal to part, 20. If I did 25, 25 is greater than or equal to 20, 50 is greater than or equal to 20, and if you try a number less than 20, it's not going to make sense. Like 19 is not greater than or equal to 20, but that's not part of the answer set. So here's one for you to try, a couple for you to try. Go ahead and solve these inequalities, and then, or hit pause, solve them, and then hit play when you're ready. All right, we're back. So 1a, if I have 22 is greater than m minus 8, I can add 8 to both sides and get 30 is greater than m. So the set would be the set of all numbers greater than 30, or the set of all numbers less than 30. So be careful with this one. This says 30 is greater than m, which means that if you're trying to plug numbers in for m, all those numbers would have to be less than 30. Okay, so just be careful because this one's set up the other way. All right, it means the same thing as if it was written m is less than 30. Okay, because if you read it from left to right, you read it as 30 is greater than m. So that means that m has to be any number so that 30 is greater than it, which is going to be all numbers less than 30. Okay, so d minus 14 is greater than or equal to negative 19. So you add 14 to both sides, and you have d is greater than or equal to negative 5. So as long as your number is negative 5 or more, so like negative 5, negative 4, negative 3, 0, 1, 7, 15, 200, any of those or greater than that, it's going to work. All right. So a more concise way of writing a solution set is to use set builder notation. In set builder notation, the solution in example 1 is this right here. You can read that, the set of all x such that x is greater than or equal to 20. So the solution set can be graphed on a number line, and be sure to check if the endpoint of the graph of an inequality should be a circle or a dot. I like to think of that as the boundary point. If the endpoint is not included in the graph, use a circle, which the circle indicates that you can go up to that point but not include it. If it is included, you fill in the circle and shade it in, meaning that point is included. Okay, so this would be x greater than or equal to 20. Notice that they shaded everything above 20 because it's all numbers greater than 20, and the circle on 20 is shaded in. Okay, if it was x greater than 20, like this, you would have your number line at 20, 21. You put an open circle there and shade everything in the arrow to the right. Okay, so the open circle means that 20 is the boundary, but the boundary is not included, so it's everything bigger than 20. The closed circle means that 20 is the boundary and 20 is included, and that corresponds to the or equal to part. All right, so that's it for this first video. Stay tuned for the second half.